and you can use it for really the next generation energy storage. And we have Jens with us, who will talk about it. The floor is yours for 4 minutes, and we have 4 minutes for the answers, questions and answers.
Thanks, Holger. Yeah, ladies and gentlemen, all battery systems need power electronics. But why? Let me show you. What happens when the battery is connected directly to one of these cables? 1, 2, 3, boom. Without the right power electronics, it's a disaster. Battery storage is critical for the energy transition, everyone says. But today's systems, they are inefficient, expensive, and they don't last as long as they should. Our solution changes all that. Let me explain how. We've created a power electronics platform that integrates battery management and the inverter onto a single circuit board, placed directly at the battery cells. What does that mean? It means up to 20% lower costs, up to 90% less energy loss, and up to 50% longer system lifespan. Experts agree on the impact of our innovation. Professor 𝗕𝘁𝘁𝗶𝗵𝗵 from the Karlsruhe Institute of Technology says our approach can achieve significant efficiency gains and offer a clear advantage. Pretty impressive, right? But the real challenge for companies? Integrating battery storage into their products is hard. Off-the-shelf solutions are too rigid and costly, and in-house expertise is often unavailable. That's where we shine. By equipping each cell with its own power electronics, our solution unlocks a new level of flexibility and scalability. It is highly scalable in current and voltage, currently supporting voltages up to 1,500 volts and currents up to 200 amps. It enables smaller and lighter systems. It is built modular for robustness and easy repairs. And it is safer than any other solution. There simply are no dangerous voltages when powered off. We've created what we call a software-defined battery. This means we can provide nearly any voltage form, direct current, alternating current, or even custom voltage shapes tailored to specific applications. The result is a battery system that's not just flexible and scalable, but also perfectly adaptable to the unique needs of diverse industries. And here's the best part. We make it simply for you. Our licensing model and integration services let you leverage our platform to develop your own storage systems faster, cheaper, and more efficiently. Let's transform energy storage together. Reach out to discover how we can help. Thank you.
Thank you. This was on point. So I share your LinkedIn link directly here in the chat. Any questions to Jens? Please either connect him on LinkedIn or connect to him anyway if you're interested. But connect to him. But any questions? Floor's open. And then just one thing, please contact Jens directly. The first link, the second link is a company link to the company. You can't connect to companies. So.
Oh, okay, sorry. Thanks.
Mentioning it. So. Okay, any questions? Makes this also sense for 48 volts?
Yes, in our view, it makes sense for 48 volts because you can build standardized modules a bit smaller than right now. It's because of the form of the PCB that's taking up less space. And you can put in more cells than usual in one module. This means you have a kind of over provisioning, and one cell dies the module still works as before because we can simply skip defective cells. This is one of the big advantages of our technology. How do we isolate the 1,500 volts according to electrical safety? That's a question to our specialists. I know they were going to great lengths in isolation testing. The idea is that the cells are connected on demand, step by step. So you have high voltages only on the extreme ends of a battery pack, and between cells, at least in the off state, you have at max the one cell voltage. But if that's a real concern, contact me and I'll get you in touch with the experts. If I understand correctly, one can do battery cyclometry. Can one do this on individual cell level or a full battery? Yeah, that's a good question. And it's again very technical. I would have to get in touch. But right now in testing, we're doing it on cell level because we want to know if there's any differences in the way cells behave. And we're gathering large amounts of data right now. The idea is that the algorithms are then able to decide which state a cell is in so that we don't have to do the whole data collection all, but each cell has its own microcontroller. So yeah, specifically each and every cell is monitored all the time. Thank you. Okay.
Okay. So there's one.
Yeah,
go ahead.
Sorry, how the batteries are connected. Does our system replace the connections? Yes, it does. The batteries, the cells are connected by the same PCB where the power electronics is on. So the connection is directly from the PCB to the cell, and the cells are then connected to one another by MOSFETs that form H bridges. So we can selectively switch on and off cells, and we can also bypass them to have lower voltages.
Okay, perfect. There's also in the chat from Hans Konzin the question to connect regarding please, Hans, reach out directly to Jens. I know you're active on LinkedIn. Please connect him directly to have this discussion. So I think we're close to the end. We have a perfect timing.